Hook. Imagine a self-driving car, gliding down a busy city street. Instead of just spotting shapes or matching faces, it actually understands its surroundings, identifying moving vehicles, knowing where the sidewalks are, and even predicting if someone might suddenly step into the road. This is a leap far beyond traditional computer vision. This is AI on the verge of perception. Topic introduction. For years, AI systems saw the world in fragments, pixels, patterns, and patches. They could recognize the texture of a cat's fur or the sheen of a stop sign, but struggled to grasp the big picture. Why is this a problem? Because life is messy. Scenes are cluttered, objects occlude each other, and so-called noise, random shadows or objects out of place, confuse classic vision algorithms. Enter a revolution, a method that lets machines parse scenes more like we do, breaking the world into meaningful chunks, understanding not just that there's a chair here and a dog there, but also who's sitting on what, and which objects are interacting. Core concept explained. At the heart of this innovation is a technique that treats every image, not as a mass of colors, but as a collection of parts and their relationships. Classic neural networks assign labels to pictures: dog, chair, tree. But this approach goes further, dynamically grouping together the relevant bits of an image, segmenting each object along with its context, and then reasoning about how those objects are connected. Technically, this involves a powerful system called scene decomposition or object-centric representation. It works a bit like the way our brains process vision. First, we recognize parts, then objects, and then we reason about their position and relevance. Using advanced neural modules, the AI learns to deconstruct its visual world into slots or capsules, each one representing a distinct object or entity. Specialized attention mechanisms learn to focus on meaningful regions, making sense even out of tangled scenes with overlapping shapes, confusing backgrounds, and occlusions. Algorithms behind this breakthrough go beyond convolutional networks by leveraging approaches like slot attention or capsule networks. Rather than treating each pixel equally, these methods enable the model to infer which pixels belong together as a meaningful object, creating a structured, interpretable map of the world. Use cases. What does this mean for the real world? In robotics, an agent can pick up the right tool from a crowded toolbox, even if it's half buried. In medical imaging, AI can spot anomalies like a tumor hiding behind healthy tissue by understanding the relationships in a scan. In video analysis, a system can track players and the ball in complex sports footage, making accurate predictions about what will happen next. Autonomous vehicles are among the biggest benefactors. Being able to segment and interpret moving parts of complex city scenes is critical for safety. Even augmented reality and gaming stand to benefit, with more immersive and reactively intelligent digital worlds based on this deeper understanding of scene structure. Importance. The impact here is enormous. Instead of handcrafting features or training AI on endless variations of scenes, these new techniques let learning algorithms tackle the data head-on, picking apart and rebuilding scenes automatically. Suddenly, AI can generalize better, adapt to novel settings, and crucially, its visual models become more interpretable for humans. By modeling the world in terms of objects and their relationships, just as humans do, these systems bridge the gap between raw sensation and high-level reasoning. It unlocks a future where AI isn't just seeing, but truly perceiving and understanding. Q&A. Q. Can this AI handle truly chaotic or never-before-seen scenes? A. Yes, that's the magic. Because it learns to segment and relate any arrangement of objects, it can generalize far beyond specific training data. It doesn't just memorize, it deduces. Q. How does this differ from old-school object detection? A. Traditional systems label and box objects.